All right, so today we are looking at similarity. So as two shapes are similar if they have the same corresponding angles, or what they say is the corresponding sides are in the same ratio. So say for example, what that means is, so if I had a square and then I have a bigger square, yeah, they are similar. They're similar objects or shapes because they've both got 90. All their angles are exactly the same because they've all got 90, and their side, and so we could say that they are similar shapes. What we can also say, so that's like all angles are equal. So another way we could tell that a shape is similar. So I'll do another example. Say it doesn't have to be like, say I have like this house here, whatever, and then I have an enlarged version of this house shape or whatever. So say I said, all right, this was 1, this length was 1, and this length was, I'm going to say 3, okay? And then if I said this side was 2 and this side is 6. So can you see, this is what they mean when the sides are in the same ratio. Because we times this 1 by 2 and we got that 2. So because I times this other side by exactly the same number, which is 2, I got 6. That means they've been enlarged up by the same amount, and that is, therefore they're similar. So that's what they mean when they say corresponding sides are the same, in the same ratio. Now, what you multiply, say, it doesn't matter if it's enlarged up or it can be reduced down by the same amount, but what that amount that you're enlarging it by is known as the scale factor. Okay, so, and they often use the letter K. Okay, and they say linear, and what they mean by linear, just remember that's really, it means the length. So the length scale factor. So when we were measuring the sides of the house, that's a length. Okay, so we find the scale factor, so say that enlargement, that number 2, we can find it by saying the length of the image over the length of the object. So say I didn't know what the scale factor was. The way you can find it, I always like to say the new object over the original, which is the same thing, but I don't know, I just like that. If I write that word, I know I can get it right when they say like this was the new object or this is what it went to. So if you look at my example, say I said this was the original and this was my new object, what I do to see if it was, to find the K, if I said these were similar, I'd do the new object. So I pick one of the sides, I could pick this 6, and I'd go, all right, the new object's side was 6 and the original object's was 3. So you can simplify 6 over 3 and you get 2. So that's how we know that this is the scale factor. So 2 is the scale factor. All right. Now, if you were testing to see if that object up here was similar, meaning it is, you should do, when you do the same sides, it should equal the same number, which it does. So 6 over 3 equals 2 over 1. So if you look at it, this is from the side of the house. This is the side measurements. And this is, I'll just call it the roof measurement. And because when you do them over each other, they equal the same number, that means they're similar. Okay, so we can find the, obviously we can work out the scale factor. It doesn't necessarily have to go big. You might be reducing it, so we might be down scaling and that would be when you have the small over the big. So if we went the other way, the scale factor would have been a half, because you're halving it, and then obviously if we're going up, it does that. So yeah, so this is going to be our formula to find the scale factor. And remember, this is a length measurement. So when we talk about the scale factor, it's the length measurement. Okay, so two shapes are similar. The ratio between the two sides can be given. So sometimes they write the scale factor as a ratio. So say in this square example, instead of saying they'll say it's a 1 to 3, okay? But the scale factor is 3. So if you think about it, because if we do our formula, scale factor equals new over original, we would have had, this is the new, 3 over 1. So there we get the scale factor. Sorry, you can't see that. The scale factor of 3. All right, so let's just have a look at some other examples. So we can have many shapes that are similar. So here we would have, if we have two circles are similar because their angles are the same, because they've both got 360, so that they were similar. So say I was finding what the scale factor was from going from this shape to that shape, it will be 4 over 3. Okay, that would be the scale factor. The new image was 4 over 3, so I do a length. That's how much it's enlarged by. All right, so then if you look at the two squares are similar. Now we know a square, because they told us it's a square, we therefore know that the angles are the same and the length sides. So this is another one, and its scale factor would be the same if we were going this way to that way. So scale factor would be, you compare the same sides of the shape, so 4 over 3. Now, be careful, a rectangle is they may not be similar. And this is where I'm talking about here. The sides would have to be in the same ratio, meaning you get the same thing. So if I call this the new image and this the original, so this length, I've got 8 over 4, but that should equal this side over that side. It doesn't equal 1 over 1, does it? So therefore, that does not equal. So these shapes are not similar. Okay, so that's what happened. If you look at this one, the next one, it is, because if I go 8 over 4, does that equal 2 over 1? It does, doesn't it? So this one they are similar. So just be careful. All the sides have to have gone up by the same amount. So you can, once you know that they are similar, obviously you can find out unknown sides. So here, you're going to have to be careful. You look for in the question and you'll notice they'll tell you. So now that they've told me that these triangles are similar, that means that like up here, when you do their sides in as a fraction like that, they should equal each other. So knowing that, I can set this up. So say here, I'll call this the new and this the original, okay? So I could say this side over that side, x over 5, needs to equal 12 over 4, all right? So when you set this up, just make sure that when you look across this way, so when we look across this way, these have come from the same shape. So what do I mean by that? They are both pieces of information from the new object, yeah, the new shape. And if you look across here, this way is the original. They're both from the original shape. And then obviously when you look down that way, like looking down this way, they're the corresponding sides. So corresponding, sorry, can't spell, sides. Okay, so the X and the 5 are the slant bit of the triangle. So once you've got, I've made it a bit messy, but once you've got that set up, that fraction, so we would have set this up and we can say that that equals like that, you can simply just put solve in your calculator, comma X, and find it that way. So we're not testing your algebraic skills in this subject. We are testing that you can set up that formula. That's all we need you to do. So just if you're not quick at doing rearranging, just put it in the calculator exactly how you've set it up. That's fine, and do the solve. Okay, sometimes I think just going with one method and doing it every time, you'll find you go better. All right, so I get X equals 15 centimeters. So there, I found that one. All right, okay, so with this question, they're asking us to do the scale factor and then find the values of the unknown. So with this first one, when I go to find the scale factor, we will need to use a comparison of sides. So I will use, say this one, 200 and a 50. So I'm going to call this the original and this the new. So they should have really told us which way it's going, but I'm just going to say that way. So the scale factor for this one would be 200 centimeters. Oh, sorry, we're going to write the rule. So which is the new over the original. Sorry, so we're going to have 50 over 200, which is 1/4. So this one, it's reduced by 1/4. Okay, when we need to go find the unknown side, so say like, for example, we're going to find X here, we're going to use the corresponding side scenario. So we're going to say we've got the 200 over 50, and we're going to say equals the X over 70. Okay, and then we'll use solve, comma X. Okay, so what we're looking for is to make sure that this way is coming from the same shape, so that they're the same, this is the same shape. So this is both, those numbers are from the original shape, and this 50 and 70 are from the new shape. When you looking down this way, you are looking that it's the corresponding sides. So just to make sure that you are setting it up right, and then you can find corresponding side. So we could set up the same, use the same 200 over 50 to find the y, and I would say is y over 50 because that's 50 as well, and we can use solve, comma y, and just we won't go through that on the calc, we'll just let you work them out, but that's the setting it up. So here with this one, with the scale factor, we do need to make sure we're using the same units, because otherwise we can't really say how it's shrunk properly. So I'm going to use a side we have both, and we both have this. This is 4 meters. I'm going to change that to 400 centimeters, so that I'll call this the original and this the new. So when I say I've got 20 centimeters over 400 centimeters, I can see that it is, we get 1 over 20th. So our new model of the rocket is 1/20th of the original rocket or whatever. Okay, so, and then we can use the corresponding sides. You don't need, when you do the corresponding sides, you don't have to change the units, just as long as you write what you're finding. So I could say the 4 meters over the 20 centimeters, and it's going to equal, and I'll use one of the ones I don't know, which is 25 meters over X centimeters. And when you solve that, that will tell you what X is in centimeters, because we're using both centimeters in the comparison. All right. And then you can do, just in case you're wondering, you can use the same side to find the Y. So over there it was 1 meter over Y centimeters, and you can do solve again for that. Okay, so with these, we need to be able to see the similar shapes, and the actual similar shape here is because of those parallel lines. This shape is similar to this little one inside, like that. So often with these, I like to draw them out separate, and so that I can see the corresponding sides. So this side along here is actually 10, because 8 plus 2, and I've got 8 centimeters and I've got 4 centimeters. Then my smaller similar shape, the blue one, I have 8 and I've got Y and I've got X. So this way I can compare, I can see, all right, I've got both of those, so I can set it up at 10 over 8, and then I'll use find one of my unknowns, so 8 over Y, and we can use solve there and comma Y. Okay, I could do the same, use 10 over 8 and use 4 over X and solve for X. Okay, so you guys can do that on your calculator. With this one, it doesn't matter that it's they probably will tell us that it is similar, and they probably need to tell you, but then we can just do the comparison. So look for something you've got both of, which got both that distance. So I'll say 21 over 7, and it can equal one of my unknowns. So I might say 63 over X, and we can solve and find X there. And then we can still use that 21 over 7 and find the Y. So in this case, Y is there on the big shape over 42. Then we can go solve comma Y. All right. Okay, with this question, I just wanted to show you how you can get the similar triangles with what happens is with the sun shines down and it creates similar triangles. So you often see this question. So the person and that creates a shadow, that creates your first little triangle here. So they told us she's 168 centimeters, and we know the shadow's 140 centimeters. This shape, this triangle, is similar to the triangle with the tree. So we've got this bigger one, and we've got this is 14 meters, and then we've got the tree, which I think they asked you to find the tree height here. So as long as we can use now, we've got both sides, corresponding sides. So I can leave it in the centimeters and meters, as long as you're aware that when we find that T, it'll be in a meter answer because we've used that there. So you can just pop in solve, comma T, and they converted or they found the scale factor and then times it, but we can just use it like this, and we get T equals 16.8 meters. Okay, now this next one, because of these parallel lines here along here, it sets up similar triangles. So what I'm going to show you is, say we've got this little triangle in here. So if I draw that one first, the little triangle, and say that's X, that's 3. it's similar to the overall triangle, this overall one. So if I drew that overall one, we have 5.5, and we've got x plus 6. Okay, so why are they similar? Is like, if you look, they both have this angle here. And when you have parallel lines, remember, corresponding angles are equal. So those two angles are equal. If those two angles are equal, then the last one must be the same, because they all have to add up to 180. So we can go about solving this the same way. I'm going to say corresponding sides. So I say 3 over 5.5 needs to equal x over x plus 6. And it doesn't matter that we have, more than one x. We can solve that. And we get x to be 7.2 centimeters. Okay, so with this example up here, I'm going to show you how we have similar triangles. When you have opposite angles like this, they are equal. And if you look there, they've both got a right angle. So if you have two angles that are already the same in a triangle, it makes the third one would be the same size as well. So what you can do is you can get two similar triangles out of this, but you need to just be careful, because this triangle is similar to, say, this triangle, but we want to pop them in the same way to makes it easier. So what I'm going to do is I'm going to draw the red one out again, and I'm going to mark those angles so that when I write the similar triangle, so now I'm going to draw the smaller black triangle, but I'm going to draw it in the same way, same direction as the red one. So I'll draw the the right angle, I'll mark in that green angle, and I'll mark in that purple angle. So if I look between the green and the purple is 1.26. So that means between the green and the purple along here is 1.2x. Like I said 6, sorry. And between the right angle and the purple dot, so the right angle, the purple dot is 18. So once I've got that set up, I can do similar triangles. So I can say 2x over 18, they're the same sides, must equal 36 over 1.2x. And you can then just do solve, comma x. Okay, so we found x to be 16.4. Okay, with this one, we get a scenario where they're setting up similar triangles. So they have the torch, and it is 1.2 away from the wall, and it makes a circle with a radius of 8. So we can see we create the triangle. They then move the torch back, and it an extra 2 meters. So this 1.2 becomes 3.2 meters. And when you move a torch back, it creates a bigger radius, a bigger circle. So there's our thing. So we've got our two similar triangles here, where we've got 1.2, and we can say is similar to this 3.2. So we can set up similar triangles. I can say 1.2 over 3.2 needs to equal the 8 centimeters over the radius in centimeters for this circle. Okay, so if we do solve, comma r, it will tell us what the radius. Okay, so I get the radius to be 21.3 centimeters of the bigger circle. All right.